In this video, we are going to talk about the derivatives of trigonometric functions. So for example, let's assume that we have f of x equals sine x. Using first principles, what will be the derivative of f of x? Now, we know that from first principles, f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x divided by h. So now, the function is sine x. It means that wherever we see x, we should replace it with x plus h. So f prime of x is equal to limit as h approaches 0 of sine x plus h minus sine x divided by h. So if we simplify further, this is limit as h approaches 0. Now sine x plus h is the same as sine x plus sine x cos h, then plus cos x sine h, then minus sine x divided by h. So this is equal to limit as h approaches 0. So now I want to bring this minus sine x to this place. So this will become limit as h approaches 0. Sine x cos h. Now let me differentiate it by putting this h into bracket. Minus sine x, then plus cos x sine h divided by h. So this is equal to limit as h approaches 0. Now if you factorize sine x out, it becomes sine x, then into bracket cos h minus 1 divided by h, then plus limit as h approaches 0, then cos x sine h divided by h. So this is equal to limit as h approaches 0. Now this will become into bracket cos h minus 1 divided by h times sine x, then plus limit as h approaches 0 sine h divided by h times cos x. Now this limit as h approaches 0 of cos h minus 1 over over h is 0. So all of this limit is 0. And then limit as h approaches 0 of sine h over h is 1. Now later on I will do a video on the mean value theorem of calculus. Then we will understand why this limit is 0 and why this one is 1. So this is equal to 0 plus 1 times cos x, and therefore f prime of x is equal to cos x. So what this means is that if you differentiate sine x, you will get cos x. Now if f of x was equal to cos x and we use the same first principles, then you find out that f prime of x is equal to minus sine x. You can try using the same first principles. This is the answer you will get. So it means that if you differentiate sine x, you will get cos x. And if you differentiate cos x, you will get minus sine x. Now, what if f of x is equal to tan x? What is the derivative of tan x? Now you see that f prime of x is equal to f of x is equal to tan x can also be written as sine x over cos x. So f prime of x is equal to, we need to use the chain rule in this case. Sorry, the quotient rule in this case. So we maintain cos x, then we differentiate sine x. If we differentiate sine x, it is cos x. So here is cos x, then minus, you maintain sine x, then you differentiate cos x. If you differentiate cos x, you get minus sine x. Then you divide by the square of the denominator, which becomes cos squared x. So f prime of x is equal to, this becomes cos squared x, then minus sine x becomes plus sine squared x divided by cos squared x. So f prime of x is equal to, remember the identity, cos squared x plus sine squared x is equal to 1. So it becomes 1 divided by cos squared x. Now 1 over cos x is equal to sec x. So 1 over cos squared x is equal to sec squared x. And therefore, if you differentiate tan x, you are going to get sec squared x. So what if f of x is equal to sec x? What is f prime of x? We know that sec x is the same as 1 over cos x. So f prime of x is equal to, maintain cos x and differentiate the denominator. If you differentiate 1 is a constant, so it is times 0. Then you subtract it from, maintain 1 and differentiate the denominator, which is cos x. If you differentiate cos x, you get minus sine x, then divided by the square of the denominator, which is cos squared x. So f prime of x is equal to, now cos x times 0, this becomes 0, then minus 1 times minus sine x becomes plus sine x divided by cos squared x. So f prime of x is equal to, now sine x divided by cos squared x. I want to write it as cos x cos x. So f prime of x is equal to sine x over cos x, then times 1 over cos x. So f prime of x is equal to sine x over cos x is the same as tan x, and then 1 over cos x is sec x, so it becomes sec x tan x. So if you differentiate sec x, you are going to get sec x tan x. Now what if f of x is equal to cosec x? What is f prime of x? We know that f of x in this case is 1 over sine x. So just as what we did here, f prime of x is equal to, maintain sine x and differentiate the numerator, which is, if you differentiate 1 is a constant, so it is 0, then minus, then differentiate the denominator, which is sine x. If you differentiate sine x, you get cos x, and you divide it by the square of the denominator, which is sine squared x. So f prime of x is equal to, now sine x times 0 is 0, 0 minus cos x divided by sine squared x. So f prime of x is equal to, I want to write this as minus cos x divided by sine x times sine x. So f prime of x is equal to minus cos x divided by sine x times 1 over sine x. So f prime of x is equal to cos x over sine x. Remember we said that sine x over cos x is tan x. So cos x over sine x is the same as 1 over tan x, which is cot x. So, and 1 over sine x is cosec x. So we are going to get cosec x cot x. But remember there's a minus here, so it is minus cosec x cot x. That is the differential of cosec x. So if you differentiate sec x, you will get sec x tan x. But if you differentiate cosec x, you will get minus cosec x cos cot x. So what if f of x is equal to cot x? What is the differential of cot x? So in this case, f of x is equal to cot x is the same as cos x over sin x. So now f prime of x is equal to, maintain the denominator, which is sin x, then differentiate the numerator. If you differentiate cos x, you get minus sin x, then maintain the numerator, which is cos x, then differentiate the denominator. If you differentiate sin x, you will get cos x divided by the square of the denominator, which is sin squared x. So f prime of x is equal to sin x times minus sin x becomes minus sin squared x, then minus cos x times cos x is cos squared x divided by sin squared x. So f prime of x is equal to, you can factorize 1 out of this, so this becomes minus 1 times sin squared x plus cos squared x, then divided by sin squared x. So f prime of x is equal to, now sin squared x plus cos squared x is 1, so it becomes minus 1 over sin squared x. Now 1 over sin x is cosec x, so minus 1 over sin squared x will make f prime of x equals minus cosec squared x. So if you differentiate cot x, you will get minus cosec squared x. So now let's remember the things we've already established. So we have established that if you differentiate d dx of sin x is equal to cos x, and then if you differentiate cos x, you are going to get minus sin x, and then if you differentiate tan x, you are going to get sec squared x, and then if you differentiate cosec x, you are going to get minus cosec x cot x, and then if you differentiate sec x, you will get sec x tan x, and then if you differentiate cot x, then you are going to get minus cosec squared x. So using this understanding, if y is equal to 8 sec x minus 5 cos x, what is y prime? So y prime is equal to 8. If you differentiate sec x, you are going to get sec x tan x, so 8 sec x, so y prime is equal to 8 sec x tan x, then minus 5. If you differentiate cos x, you get minus sin x times minus sin x. So y prime is equal to 8 sec x tan x, then minus 5 times minus sin x becomes plus 5 sin x. Now what if y is equal to cot x minus 7 cosec x? What is y prime? Y prime is equal to, if you differentiate cot x, you are going to get minus cosec squared x, then minus 7 times, if you differentiate cosec x, you get minus cosec x quot x. So times minus cosec x quot x. So y prime is equal to minus 7 times minus cosec x quot x becomes 7 cosec x quot x, then minus cosec squared x. Find ddx of quot into bracket 2 plus 5x plus 3x squared. So we know that if you want to differentiate a function of a function, this is a composite function, you first differentiate the function inside the bracket before you differentiate the whole function. So this is equal to, now when you differentiate what is inside the bracket, if you differentiate 2 is 0, if you differentiate 5x, it is 5. Then if you differentiate 3x squared, it is 6x. So it becomes 5 plus 6x. Then you then differentiate the whole function. If you differentiate cot x, you are going to get minus cosec squared x, and the x in this case is 2 plus 5x plus 3x squared. So at the end of the day, the answer becomes minus 5 plus 6x divided by, now cosec squared x is the same as sine squared x, so it becomes sine squared into bracket 2 plus 5x plus 3x squared. So if y is equal to ln sec x divided by 1 minus tan x, what is y prime? So y prime is equal to, we need to use the quotient rule. So we need to maintain the denominator, which is 1 minus tan x. Then we differentiate the numerator. So in differentiating the numerator, we need to first differentiate what is inside the ln. Remember that if you have ln j of x, then the derivative of ln j of x is equal to j prime of x over j of x. So if you differentiate sec x, you are going to get sec x tan x divided by sec x, then minus, you keep ln sec x, then we differentiate minus tan x. If you differentiate tan x, you get sec squared x, so it becomes minus sec squared x, all of that divided by the square of the denominator, which is 1 minus tan x squared. So this sec x and this sec x can cancel out, so y prime of x, or y prime, is equal to, into bracket 1 minus tan x, then tan x, then minus ln sec x minus sec squared x becomes plus sec squared x ln sec x, all of this divided by 1 minus tan x all squared. So now if f of x is equal to 2 cos x minus 6 sec x plus 3, what is f prime of x? It's equal to, so we need to differentiate cos x. If you differentiate cos x, you get minus sine x, so it becomes minus 2 sine x, then minus, now 6, let's differentiate sec x. If you differentiate sec x, you will get sec x tan x, so here's sec x tan x. Then if you differentiate 3 is 0, so f prime of x is equal to, let's factorize 2 out, we'll be left with sine x, then plus 3 sec x tan x. So this is the final answer. So what if f of x is equal to tan x sec x? What is f prime of x? So to differentiate this is product of two functions. So what we will do is that we will maintain tan x, then differentiate sec x. If you differentiate sec x, you will get sec x tan x, then plus maintain sec x, then differentiate tan x. If you differentiate tan x, you will get sec squared x. So f prime of x is equal to, this becomes sec x tan squared x plus sec cubed x. What if we have z of x equals x plus tan x divided by 1 plus cosec x? What is the derivative of z of x? So z prime of x is equal to, maintain the denominator because we are using quotient rule. So in this case, it becomes 1 plus cosec x. Then differentiate the numerator. If you differentiate x, you get 1 plus. If you differentiate tan x, you will get sec squared x. Then minus, maintain the numerator, which is x plus tan x. Then differentiate the denominator. If you differentiate 1 is 0. But if you differentiate cosec x, it is minus cot x, then cosec x. All of that divided by the square of the denominator, which is 1 plus cosec x squared. So z prime of x is equal to, now this is minus and this is also minus, so we can multiply the two. So if you multiply the two, then you are going to get plus here. So at the end of the day, it becomes into bracket 1 plus cosec x, then times 1 plus sec squared x, then plus into bracket x plus tan x, then sec cosec x cot x divided by into bracket 1 plus cosec x all squared. So what if y is equal to cos 7x? What is the derivative of y? So you differentiate this. If you differentiate 7x, you get 7 times. If you differentiate cos x, you get minus sine x. So it becomes times minus sine 7x. So y prime is equal to minus 7 sine 7x. If f of x is equal to cot 3x minus 2x squared, what is f prime of x? F prime of x is equal to, you differentiate 3x minus 2x squared. So if you differentiate 3x, you will get 3. Then if you differentiate minus 2x squared, you get minus 4x. Then times, if you differentiate cot x, you will get minus cosec squared x, and this becomes 3x minus 2x squared. So this is f prime of x is equal to minus into bracket 3 minus 4x divided by cosec is the same as 1 divided by sine x. So in this case, it becomes sine squared into bracket 3x minus 2x squared. So f prime of x, we can kill this negative by writing 4x minus 3 divided by sine squared 3x minus 2x squared. Finally, if we have f of x equals tan x plus 9 cos x, what is the tangent at x equals pi? What's the tangent to this line? Assuming f of x is a line. So tangent is the same as f prime of x, which is equal to, if you differentiate tan x, you will get sec squared x. Then if you differentiate cos x, you get minus sine x, so it becomes minus 9 sine x. But then we are finding the tangent at x equals pi, so we need to find f prime of pi. So we just insert pi here. So if this becomes sec squared pi minus 9 sine pi. Now, sec squared is the same as 1 over cos. So it's the same as 1 over cos pi. So this can also be written as 1 over cos squared pi minus 9 sine pi. Now, cos pi is the same as cos 180. Cos 180 is 1. 1 over 1 squared is 1. So f prime of pi is equal to 1 minus sine 180 is 0. So 0. And therefore f prime of pi is equal to 1.